Hello, and welcome to Math Matters. I'm Miss Ogden, and today we're going to learn about some of the different parts of a circle, the relationship between those parts, and how we can use those relationships to define pi. For this lesson, you will need paper and a pencil or something else to write with. We will pause while you take a moment to gather those materials. Now that you're ready, let's get started. Let's begin with a warm-up. Mathematicians are always thinking about similarities and differences. Take a look at figures A and B on your screen. What is the same? What is different? Take a moment to jot down any similarities or differences that you might notice. First, let's take a look at some of the similarities. You might have noticed that one way that figures A and B are alike is that both circles are made up of many small circles, or that both circles have multiple colors inside. You might have also noticed that the circumference, or the outside of each circle, is purple. Now let's take a look at some of the differences. One difference you might have noticed is that figure A has been partitioned into 6 equal parts, and that its little circles are grouped by color, and that figure B's colors are organized into rings of little circles by color. You might have also noticed that the dark gray circles in figure A have been placed next to each other to form line segments that partition the circle into 6. These line segments cross through the center of the circle and cut it in half. Mathematicians call this line the diameter. Figure A has line segments that show the diameter of the circle, and figure B does not. Next, we'll zoom in to some of the different terms that mathematicians use when we work with circles. I bet that you've been noticing circles since you were very young. Mathematicians use specific terms to describe the different parts of a circle so that we'll all have a common language. You might be wondering about the mathematical definition of a circle. Mathematicians define a circle as a set of points that are the same distance from a point called the center. A line segment that passes through the center of the circle is called the diameter. There are an infinite number of diameters in any given circle. A line segment that starts in the center of the circle and extends to the edge is called a radius. The distance around the outside of the circle is called the circumference. We can think about circumference as the perimeter of the circle. Now that we have specific names for the parts of a circle, we will take a look at the relationship between those parts. If we take a look at the relationship between the radius and the diameter, we can see that it takes 2 radii to make 1 diameter, or, in other words, the diameter is twice the length of the radius. Another way we can describe this relationship is that the radius is 1/2 of the diameter. Next, we'll zoom in on the relationship between a circle's circumference and diameter. Take a look at the 4 circles on your screen. Let's create a diameter for each circle and connect them. Now, imagine we took a wheel that is congruent to each circle and wrapped a red string around its circumference. If we unroll the red string from the wheel, we'll be able to see the circumference represented as a line segment. As we unroll the circumference, which is represented by the red string, we can see that it is a little longer than 3 diameters. If you've ever heard of pi before, but weren't sure what it meant, this is where it comes from. The value of pi is about 3 14/100. Mathematicians use pi to determine the circumference of a circle. We know that each circle's circumference is a little more than 3 times its diameter. So, to find the circumference, or the distance around the circle, we can multiply the length of the diameter by 3 14/100. Now that we know more about some of the different parts of a circle, let's think about where we might see these concepts in real life. Mathematicians are always noticing the math that's all around them. On your screen, you see the outside of a building. Let's pretend to take a walk inside to see what math we might find. As we walk inside the building, we can see this circle in the design of the tile flooring. What do you notice? What do you wonder? You might have noticed that the circle is brown, or that there are little white square tiles around the brown circle. You might be wondering just how many of those little white tiles it took to go around the brown circle, and so am I. Before the designer could create this tiling, he had to figure out exactly how many of those little white square tiles they'd need to buy. They had to figure out how many square tiles they'd need to create the circumference of the brown circle. In a moment, we'll use what we've learned about circumference to help us figure out exactly how many square tiles the designer had to buy. But first, go ahead and make a prediction. What do you think might be a reasonable estimate for the number of square tiles that were needed to wrap around the circle? Now that you've made an estimate or prediction, let's get a little more information about this circle to help us answer the question: how many square tiles are wrapped around the circumference of this circle? We now know that the diameter is 52 tiles. Take a moment to revise your prediction. Remember, the circumference of a circle is a little more than 3 times the diameter. Now that you've revised your prediction, let's take a look at how close your estimate was. As you can see, we can multiply the diameter of 52 tiles times pi, or 3 14/100ths, to get a circumference of 164 tiles. In today's episode of Math Matters, we learned about the terms mathematicians use to describe parts of a circle and the relationship between some of those parts. We also learned about pi and how to use pi to find the circumference of a circle. Next time on Math Matters, we'll continue to investigate how mathematicians can find the area of a circle. I'm Miss Ogden. I hope you have a great day and keep on counting.